Okay, some more problems from section 5.5, and this is number 71. We have the cosine of 2x equals the cosine of x, and now again we can use one of our two-angle formulas, and this is going to be the cosine squared of x minus the sine squared of x. Now remember, that's easy to derive from cosine, cosine, sine, sine, different SIGNs. Okay, so it's very easy to derive. So I want to do this because I want to get everything in terms of 1x, not 2x. So I got all 1x's. And what I can do now, I want to get everything in terms of just the cosine, because I've got a linear cosine and a quadratic cosine, so I'll try to get everything, or second power cosine, so I'll try to get everything in terms of the cosine. So the sine squared of x equals 1 minus the cosine squared of x. So I remove the parentheses, I've got the cosine squared of x, a minus 1, plus the cosine squared of x equals the cosine squared of x. So I kind of combine two steps here. One of these plus one of those is two of those, so I got 2 cosine squared of x. And I brought this over to the left, negative cosine of x minus 1. Now again, I've got a trinomial in the cosine, so I'll let z equal the cosine of x, so z squared equals cosine squared of x. So this is going to end up looking like 2z squared minus z minus 1 equals 0, and I can factor this. And I know the other, it's an easier general trinomial because I know the only way I can get 2z squared is 2z times z, and the only way I can get 1 is 1 times 1. So again, I just have to kind of noodle it out. I know this, I've got to have a negative here, so this is going to be 2 times negative, so that's going to be negative, and 1 times z. So negative 2 plus 1 is negative z, and that's negative 1, that's positive 2z squared. So in this case, if I set each of these equal to 0, I get either z equals 1 or z equals negative 1/2. But what was z cosine? So the cosine of x equals negative 1/2, or the cosine of x equals 1, or the cosine of what is negative 1/2? Well, I know the cosine of pi over 3 is positive 1/2, but I want negative 1/2, so that's going to put me in quadrants 2 and 3, because the cosine is positive in quadrants 1 and 4. And then the cosine of x equals 1, just at x equals 0, because the cosine goes sort of like this. Okay. All right, number 73. The cosine of 2x plus 5 cosine of x plus 3. And again, I can use this cosine, so cosine squared of x minus sine squared of x equals the cosine of 2x. And again, I've got 1x, so I want to get just 1x's, so this will change, this identity will change this into 1x. Then again, try to get everything in terms of the cosine, so I'll just use my Pythagorean identity. So instead of writing sine squared of x, I'll write 1 minus the cosine squared of x. Remove the parentheses, cosine squared of x, negative 1 plus cosine squared of x plus 5 cosine of x plus 3 equals 0. Okay, then we can combine these. I've got 1 plus 1 is 2 of those, and 3 minus 1 is 2. So if I simplify that, this is what I get. So 2 cosine squared of x plus 5 cosine of x plus 2 looks like a general trinomial to me, or a simple trinomial. Well, an easy general trinomial. Looks like a trinomial. So I'll use z substitution again. So I'll call cosine z, and then cosine squared would be z squared. So this is going to end up being 2z squared plus 5z plus 2 equals 0. Then I'll factor it, and again it's easy to factor. Only way I can get 2z is 2z times z. Now, I can get 2 as either 1 times 2 or 2 times 1, but since these signs are all positive, I don't have any. Just try positive, positive. Try 2 over here, that's 4, plus 1 is 5, that works. So always check it by multiplying. Then I can set this equal to 0 and say 2z plus 1 equals 0, therefore z equals negative 1/2, or z plus 2 equals 0, so z equals negative 2. So if cosine equals negative 1/2, we know the cosine of 1/2 is a pi over 3, so negative 1/2 is 2 pi over 3 and 4 pi over 3. That's going to be the second and the third quadrants because it's positive in the first and the fourth quadrant. And over here, remember the cosine is always between -1 and +1. It can't be -2, so there's no solution. Okay. All right, let's take a look at 75. Okay, so 75, we've got the sine of x times the cosine of x equals the square root of 2 over 4. And we would like to get one function. So what we do is we multiply both sides by 2. So I can make this 2 sine x cosine of x equals the square root of 2 over 4 times 2. Which 2 goes in there twice, that's just square root of 2 over 2. And now this looks like my two-angle formula. Okay? The one we talked about over here. That two-angle formula, sine of 2x equals 2 sine x cosine of x. So I can rewrite this as the sine of 2x equals the square root of 2 over 2. Now remember the period on this, because I've got the 2 here, is 2 pi over b, and b is 2, so that's just pi. Now, I did some of these in the last assignment, and I kind of worked them out intuitively by looking at the period and keep adding the period. Well, this kind of works the same way, but this is a little bit more analytical way that might be a little bit better. It takes a few more steps, but it's a little safer than trying to do it the intuitive way. You may forget about the period or what it is. So we know that we're going to keep revolving this around, so it's going to keep going around 2n pi. So we can put the 2n pi here, and this kind of gives us all the solutions. Although we only want to be on this interval from 0 to 2 over pi, we'll just stop when we cross 2 over pi. I'm sorry, when we cross 2 pi, pardon me. So we're going from 0 to 2 pi. When we get to the point where we're going to pass 2 pi, then we'll just stop generating roots. So we can say 2x equals pi over 4. Now remember, this is the sine of something equals the square root of 2. Then that something must be pi over 4 because the sine of pi over 4 is the square root of 2 over 2. Okay? But then we're going to add the 2n pi because that's what generates the additional periods. And then we'll multiply everything by 1/2 to get rid of this so we can solve for x. So that's just going to give me x, and that's going to be pi over 8, and then that's going to give me n pi. So we're going to end up adding, pi to these things to get the other roots. Well, that's what we did before. I was just adding a period. In this case, the period was pi. So we're just adding that much to get the next generation of the root because it's a periodic function. So it's going to appear in the next cycle. And we're just going to add the period to that. So that's basically what we're doing over here. This just kind of is a safe analytical way to approach it. And when n is equal to 0, if I put 0 in for n, that becomes just 2 times 0 is 0 times pi is 0. So I just have that, I'm sorry, over here. Excuse me. I'm over here. Because notice what happened. I kind of skipped a step, sorry. In other words, I've got this, so I want to find out what x is, so I multiply by 1/2. That gives me just x. If I multiply this by 1/2, I get pi over 8. But if I multiply this by 1/2, what happens? I just get n pi. Well, that was the one period that I was adding before. Now, when n is 0, this just drops out, so I have pi over 8. But when n is 1, if I put 1 in here, I've just got 1 pi. So I've got pi over 8 plus pi, ends up being pi over 8 plus 8 pi, which ends up being 9 pi over 8. So there's your solution for that part of the answer. Now, this accomplishes the same thing that we did before. It's just a little bit more deductive, going from step to step rather than using intuition. Now, we had another possibility, remember. If something is equal to the square root of 2, the sine of something equals the square root of 2, that something could also be 3 pi over 4. All right, because the sine of 3 pi over 4 is also equal to positive the square root of 2 over 2, because it's in the second quadrant. So we'll do the same thing. We'll say 2x equals 3 pi over 4 plus 2n pi. Then I'll multiply everything by 1/2. That becomes 3 eighths pi, and then 1/2 of that just becomes n pi. So that's another, we're going to add another period to this. So when n is 0, okay, this drops out, and I just have 3 pi over 8. When n is 1, I've got one of these, so I got pi, and I add to the 3 pi over 8. Okay? So I got n pi, so when n is 1, I add pi to that, so I got 3 pi over 8 plus pi. That's the same thing as 8 over 8 pi, which is the same thing. When I add these, 3 plus 8 is 11, so I got 11 pi over 8. So these are your 4 solutions. 2, 3, 4. And those solutions come from the fact that normally I have 2 solutions, but since I made this change, now this new function has a period of pi, then I'm going to have twice as many solutions. Because for every period or every cycle, I have 2 solutions. Okay? So that's 75, and that's a little more complicated because of this technique, so try to make sure you kind of master that technique because it's very handy.